Okay, so we're going to look at experiment number 18 to measure the amount of dissolved oxygen in a sample of water by means of a redox reaction. So I'm just going to skip ahead to our results section. So the volume of water analysed was 100 centimetres cubed, and the molarity of the sodium thiosulfate is 0.02. And then you're going to have different titrations here. It says titration 3 if possible, so that depends on the bottle size, what's available for you to use. So if you're doing this, or if you're watching this video before the titration, just try and be accurate and do the experiment as slowly as possible so you can ensure these results are accurate and you don't overshot and lose some of the water that's analysed. So the average titer, you just take the two closest ones, add them and divide by 2. So now we're going to be looking at this section here. So here are the equations or the reactions that are happening within this experiment. So we are linking the reducing agent and the oxidizing agent together. So the oxidizing agent is the oxygen, the reducing agent is the thiosulfate. So we need to link these two somehow to get the ratio between them to be able to use this formula. So you can see that they're not actually together in any of these equations. So the oxygen is here, the thiosulfate's down here. So we need to balance them out or link them in some way. So to do that, we look at the equations and we work with the 3 equations at once. So if we start off here, we have a 2 linked to the sodium thiosulfate. What I'm going to do is I'm going to look for the iodine. Now I know there's iodine up here, and the number in front of this iodine and the number in front of this iodine is the same, so I can go directly up. That should be okay. So the number of moles of iodine that I have here is the exact same as here, 1 and 1, same ratio. Now if I look over here, we have our manganese hydroxide, and that's a 2. That's also linking up to this equation. So it's like a ladder that I'm following up. This is a 2, but that's a 4 up there. So there's an inequality here. Now to get to my oxygen, I need to address this inequality. So that's a 4 magnesium hydroxide. So I need to make this a 4. So underneath here, I've just multiplied this whole line by 2. So I've got 4 manganese hydroxide, 4 iodine ions, 12 hydrogen ions, 2 iodine, 12 H2O, and 2 manganese, or 4 manganese. So I just multiplied everything by 2 to get this 4 and 4. So now they're equal. But I need to go backwards and check. Now at the moment I've got 2 iodines. Here I've only got 1. So I need to multiply this line by 2. So 2 iodine, 4 thiosulfate ions, 4 iodine ions, and then this is also multiplied by 2. So we go back up the ladder, see if we can work everything out. We've got 4 thiosulfate links with 2 iodine. That 2 iodine links with this 2 iodine. That 2 iodine gives 4 manganese hydroxide. 4 manganese hydroxide links with 4 manganese hydroxide. 4 manganese hydroxide links with 1 oxygen. So now I can link these circled ones together perfectly because everything followed the ladder and the numbers matched. So 1 mole of oxygen will produce 4 moles of thiosulfate. So that's where we're getting the 1 to 4 ratio. So once we have that, we can fill in our table. We used 100 centimetres cubed of the water. The oxidizing agent for oxygen is 1. The number of moles for the reducing agent is 4. That's what we're just after working out. This is your average titer, and this is the molarity of the thiosulfate that you used. So the only thing we need to find is the molarity of the oxidizing agent, basically the concentration of the oxygen in our water sample. So we'll go over here and we'll work out our calculations. We're using that formula. The only thing that's missing is the oxidizing agent. This is my number here. I got 3.425 by 10 to the minus 4 moles per litre. To convert that moles per litre into grams per litre, use the normal formula. Number of moles equals mass over relative molecular mass. Remember, oxygen is O2, so it's 2/16 for the relative molecular mass, which is 32. So take your number of moles and then multiply it by 32, and you get the mass in grams per litre. So I got 0.01096 grams per litre. It wants it in the end in parts per million. We know parts per million is the same as milligrams per litre. To convert grams to milligrams, move the decimal place 3 jumps to the right. So that is going to be 10.96 milligrams per litre, or 10.96 parts per million. And that's the amount of oxygen in your water sample.